This is the video for Algebra 1 Summer School, Unit 2, Lesson 1, Calculating Slope. This is the practice video. So I'm going to do a few problems here. If you have questions on any of the other problems that are on the practice, you either need to go to Canvas and reference the answer key sheet, or you need to come into office hours and speak with your instructor. All right, so we talked about calculating the slope of lines. The first problem here, number 1, is calculating the slope from a graph. We need to remember that slope is, when we look at a graph, rise over run. So rise means I always have to do the up and down part first. This graph plotted 2 points for us. The slope looks negative because it's going down from left to right, so I'm going to go down as my rise. I end up going down 1, 2, 3, 4. So down 4 over 1, 2. So down 4 over 2. That slope simplifies to negative 2. Because there's a negative sign in front here, and because the slope is going down from left to right, we say that this slope is negative. The next problem we're going to do is number 6. Here I'm given 2 ordered pairs in order to calculate the slope. Well, we need to remember that the slope, using the formula here, is y2 minus y1 over x2 minus x1. In order to keep organized, if you want to, you can label each ordered pair. I have an x and a y for each ordered pair. 1 gets the subscript of 1 because it's our first ordered pair, and 1 gets the subscripts of 2. Well, from this example, it looks like 0 is the first number I write down. 0 minus 4 over 2 minus 2. Right? So when I get 0 minus 4, that's negative 4 over 0. Now don't be tricked. Don't write this as 0. Whenever I have 0 in the denominator, this is what Slope Dude said was the curse word of all mathematics, undefined. This slope would end up being on a vertical line if we were to graph those points. Right? Number 8 here. Let's look at this one. So again, I'm still using the same slope formula that I was using the last time. The change in y's over the change in x's. I label each point x1 and y1, x2 and y2, and I put them into the slope formula. So I start with negative 3 minus 3 over 5 minus negative 5. We need to be really careful. There's a lot of negatives in this problem. Well, negative 3 minus 6, negative 3 minus 3 is negative 6. And 5 minus negative 5 is like adding 5 plus 5, which is 10. That fraction ends up simplifying into negative 3 over 5. So negative 3 over 5 is the fully simplified slope. The last problem that we're going to look at here is number 9. We're going to determine the special slopes below. That means they're not going to be positive or negative. They're going to be 0 and undefined. Those are the tricky ones. All right, in case it's hard to see, this is the line that we are looking at right here on this graph. The slope, this is a horizontal line. Every horizontal line has a slope of 0. The next one is a vertical line, and every vertical line has a slope that we say is undefined. Same when I look at a fraction. If I have a 0 in the numerator, I am allowed to divide 0 by another number. That slope ends up being 0. But just like example 6, when we did example 6, when I have 0 in the denominator, that's a bad thing. That's when we say the slope is undefined. All right? So a positive slope, negative slope, 0, and undefined slope. Again, if you have questions on any of the other problems on this practice, look at the answer key posted on Canvas or come into office hours and ask your instructor for help.